Hi guys, today I am going to present a seminar on torsion test. How the torsion test is applied in many industries. Now seeing about the torsion test. The introduction to torsion test. I just give a simple key points on introduction. I elaborate that points in briefly. Torsion refers to the twisting of material when a torque or a twisting moment is applied. In this experiment, we consider a cylindrical bar subjected to a torsional movement. The torsional movement can be represented as mt. When the bar is twisted, the twisting action is resisted by shear stress developed inside the material. The shear stress is zero in which shaft at center of the shaft the stress is shear stress is zero. It increases gradually from the center toward the surface. From center toward the surface increases gradually. The maximum shear stress occurs at the outer surface. So now maximum shear stress occurs at outer surface only. Okay, this behavior is very important in the designing of shafts, axles and rotating machining paths. Now coming to the next point of torsion equation. Now coming to the torsion equation, the applied torsional moment is given by mt equal to integral of t into r dA. This equations shows that the torque is the sum of shear stress multiplied by radius and area over the entire cross section. By rearranging the above equation, we get the standard torsion equation, which is mt equal to t divided by r integral r square into dA, in which the t stands for shear stress, mt torsional moment stands for mt, and r stands for radial distance, j stands for polar moment of inertia. This equation helps us relate applied torque, shear stress and geometry of shaft. Now coming to next point of polar moment and shear stress. Polar moment represents the resistance of a shaft to twisting and is defined as j equal to integral of r square into dA. Using the torsion formula mt divided by j equal to t divided by r, we can calculate the maximum shear stress occurring at the outer surface. For a cylindrical shaft, it stands for T maximum equal to 16 mt divided by pi dq. For a hollow cylindrical shafts, it stands for T max equal to 16 mt divided by pi into d power 4, capital D power 4 minus small d power 4, where capital D stands for the outer diameter, small d stands for the inner diameter. So these formulas are widely used in mechanical designs, so that to ensure the shaft does not fail under torsion. Now coming to next point of torsion testing equipment. Torsion testing equipment, it has twisting head, weighted thin walled. Torsion test is less widely used than tensile test. These points represents the torsion test is performed using a torsion testing machines. Torsion testings are performed using torsion testing machines. So the main components are specimen, it's also called as test shaft, and next fixed and rotating X, and next testing torque measuring device are main components, and one more is angle of twist indicator. During the test, one end of the specimen is fixed stable, so torque is gradually applied at the area. So now one end of the specimen is fixed, one end the specimen is fixed, so now the torque is gradually applied to the other end. The angle of twist and applied torques are the angle of twist and applied torque are recorded until failure. Now coming to next point of modulus of rigidity. Now coming to modulus of rigidity, also called the shear modulus. Modulus of rigidity is also called as shear modulus. Modulus of rigidity can be defined as the shear stress to shear strain. Understand that it is defined as the ratio of shear stress to shear strain. From torsion relation G equal to T divided by R. It can be also rearranged G equal to MTL divided by J theta, where theta is represented as angle of twist in radians and L be the length of the specimen, J be the polar moment of inertia, MT stands for applied torque. The modulus of rigidity indicates the material resistance to shear deformation. Higher G means the material is more rigid, lower means the material is not more rigid. That we need to understand. Now coming to next point, modulus of rupture determined from ultimate torsional shearing stress. Substitute measured torque in torsion equation. Slight observed estimation may occur. Graph between twisting moment versus angle of twist. Now I will clearly explain about the modulus of rupture. It is determined from the ultimate torsional shear stress. The maximum torque at failure is substituted into the torsion equation. It can be also represents the maximum shear stress the material can withstand before fracture. Now you want to clearly understand this point. It represents the maximum shear stress the material can withstand before the fracture. Okay, sometimes slight overestimation may occur because or due to assumptions made in torsion theory. Sometimes slight overestimation may occur due to assumptions made in torsion theory. Now graph I told about twisting moment versus angle of twist. In the torsion shears we plot a graph between twisting moment is called as torque and versus angle of twist. Initially the graph is linear. So this represents the elastic region. After yield point the graph becomes non-linear. Finally fracture occurs at the maximum torque. From this graph we can determine modulus of rigidity, the yield point and ultimate torsional strength. Once again I can able to say that from this graph we can determine modulus of rigidity, yield point, ultimate torsional strength. Now coming to the conclusion of torsion test. The conclusion of torsion test is the torsion test helps determine shear properties of materials. It helps to determine shear properties of materials. It is mainly I already told it can be used for shafts, axles and rotating machine elements. That also the torsion test is applied. Important parameters are obtained in torsion test are maximum shear stress, modulus of rigidity, modulus of rupture. Okay, thank you.